Oh, you're not by yourself.
Okay, so I handed back tests. If you think I have misscored something, either because I can't do math, which is totally possible, or because you think you conceptually have it right, I welcome people coming to my office and arguing with me. So yeah, feel free to do that. For the most part, everybody did great. So good job. The next thing to think about is the project. So we will have a project proposal due on November 5th. So that's a little less than 3 weeks away. And I think that's just a one-page, it's in the syllabus, but it's just like a one-page report on what you think you want to do. I'll put some more details on the website, but give me an idea of like, where are you going to get your data? What do you want to do to it? What's your final objective for this little project? If you don't have a data set and you don't know what to do, come talk to me. I'll be happy to give you data from my lab, which would be fantastic for me. So I welcome that. Examples of scope. Narilla said a few people had asked him about scope. I've seen people like take a small RNA-seq data set and go all the way through to differential gene expression and just have maybe a list of genes at the end that they can present. They may not have like the full interpretation of exactly what this means physiologically for their system, but they've got a really good idea of like, you know, these are what's differentially expressed. So things like that, or I have 2 samples and I want to call variance between them, or, you know, something like that. If you want to go completely off the rails and like, I had somebody do this crazy synthetic biology project 2 years ago that was awesome, and I still don't even understand all the nuts and bolts, but she just really wanted to learn how to use all these computer programs that she didn't know how to use. And so just because I'm not an expert in it doesn't mean you can't do it. Part of the class is learning how to do things. It should be something that you have to do on a computer, preferably on Linux. If you go to the Bioinformatics Resource Center and use CLC Bio and just point and click, that's not really a very good project because you're not using any of the skills you use in class. So hopefully that answers your questions about, if you have any more questions, feel free to stay after and we can go through them. So yeah, about 3 weeks when that one-page proposal is due. So a few concepts that you should be starting to wrap your head around now that we have begun with Python. Let me open a terminal and make this bigger. So just for the time being, I'm just going to type on the command line. So let's say we have the statement print my string dot count. Okay, so I already said the first thing. This is a statement. So when I say statement, I mean an entire line of code. And I kind of think about that like a statement in English, you would expect it to be a complete thought. So in this case for Python, it's the whole line of code. It's not any little sub part of it. So when I say statement, I mean the whole line. Now, what part of that is a function and what is a method? Yeah.
Function is the print.
Yes.
And the method is the count.
Yes, and how do you know that?
That is the function, I guess, always comes before the print. But the count always comes up.
Yes, so that is essentially right. A function can just be hanging off on its own. I'm, you know, a Python function. I don't need to be attached to anything. Just flying solo. A method has to be attached to something. It's attached to an object with a period. They both have parentheses, but that's the difference. So the method, the count method, has to specifically be attached to a string because it only works on strings. Whereas the print function, the print's like, dude, I know how to print all sorts of things, whatever. So that's the difference between a function and a method. What part of this is an argument? Yeah. And is there another argument in there? Okay, so yes, my string.count A is an argument to print. What is the argument to count? Okay, yes, so we've got an argument nested in an argument. Let's try, so what if we had, what do we call my string? Variable. I'm going down the list, so that seems like kind of an easy one. Okay, this is a string. We talked about string is a string of characters, so letters, numbers, symbols, but inside of either single quotes or double quotes. That's what makes a string. How do you define a list? So what if I want to say my list equals, what would be the next thing I would type? Square bracket. And let's say I wanted to have a list of numbers. How would I separate them? So that would be a list of 3 numbers. What does the special character /n do? New line. What is a /t have? What is concatenation? Sticking 2 things together. Oh, in this case, what are the list elements? The 2, the 4, the 5. So the list is the whole thing. The list element is each individual part. White space matters in Python. So we'll see that a bunch today, and we'll talk about it as we go. But indentations, you have to indent consistently. Decide now, are you a tab person or are you a space person? And stick with it. And don't have lines all over the place. Your indentation, we'll see 2 levels of indentation today. So it's gonna be really important you have your plan down. And for loops, we'll see those again today as well. So any questions? Everybody feeling good about Python?
So does Python generate kind of figures? Like can you generate a figure?
It's not native to Python. Well, I don't think native to Python, but you can go get libraries that do that. Yeah. It's just like R. You know how you're always like getting a library in R. Usually it's make figures like gplot, ggplot. In Python, there's a similar library that you can use to generate figures. Yeah. Although I will say, well, I don't know if I can say that. I don't know if I've generated enough figures in Python, but R generally has really nice figure functions and libraries. So it may have a leg up on Python on that one. Okay, I'm gonna log into the ACF. Again, if you have Python on your own computer, this should all work identically without a problem. Okay, so I'm gonna go to my Python practice folder. Just go to your own directory. I've got a whole bunch of stuff. I'm actually gonna make a directory called hide and move everything into hide, just because it'll be less messy. Okay, so most people are probably, well, some people are done with their homework, some people are not. I expect you're getting a lot of emails this afternoon and this evening. But part of the program that we were writing was to calculate the AT content of a DNA sequence. I think it was GC in the example, like I can't remember. It was some kind of content. So it would be really convenient if you could just use a little function like get AT content, and it would just magically work and give you the result that you want. Of course, Python doesn't have that function natively, but there's a way that we can create our own function so that once you write something, you can encapsulate it into a function and reuse it over and over and over. It also means that if you're writing the same thing over and over, like let's say your lab's really concerned about GC content and you're like constantly running GC content analysis. If you have this function living in like 20 different places in your code and you find a bug and you only fix it in one place, then you still have lots of places in your code that are broken. But if you just have like this one function that you're calling all the time, if you find a bug and you fix it, it'll get fixed permanently, and every time you call it, it'll work the way you expect. Putting things in functions also makes them easier to share. But most importantly, when you're learning, especially when you're learning to program, functions are great for breaking problems down into smaller pieces. So often you're confronted with some really big programmatic problem and you're not really sure how to tackle it. You can break it down to like, well, if I could do this little thing and then this little thing and then this little thing, that would solve the whole problem. And then you write each one as a small digestible function you feel confident you can tackle, and then they all work together to make this much more complex whole. So functions are important. So let's look at taking some code and turning it into a function. So, oh, not BI. I'm going to call it function.py. So just for some simplicity's sake, let's do, this should very easily, we should know this will come out to be a 50% AT or GC content. So that'll be a nice string to just start with. If you remember learning the count function, that takes a string, the string out front, and it counts the number of times it sees the argument string. So in this case, we're going to count the number of A's that are inside of this my DNA variable string. I think that was the one I gave you in the homework because we hadn't really covered how to do arithmetic in Python, but it's pretty straightforward. Yeah, I don't know where those are controlled from. Better? And then I'm going to log into another terminal so I don't have to keep switching back and forth. Okay, so this is my starting code, and I have logged in on a second terminal so that we can run it. And we want to remember to do our module load Python 3.6.1, I believe. Yep, I like that, good. Python 3.6.1, so that's good. If you don't do that, you'll know because you'll get really crazy results, like all your AT and GC contents will always be 0. And that's when you'll know that you forgot the module load. Okay, so we've written a little piece of code that takes a string of DNA. We can put anything we wanted in there, gets the length, it gets the number of A's, the number of T's, calculates the AT content, and prints it out to the screen. So what if we wanted to make this into a function? The first thing we would want to do, the first thing you do when you're defining a function is say def, and that is for define. So def is shorthand. When you define a function, so it's important to realize when you're writing functions that defining a function is different than calling a function. It's like building a car versus driving the car. What we are doing is we are building a structure that we can use to run code. But just because it's appearing in the file, when Python sees the def keyword, It says, all right, I'm about to learn about a function. I don't need to execute the function. I'm just going to learn how it works. So let's see that. Just like variable names, it's usually good to name your function something that says what it does. Morgan?
You have AG, but then.
Oh, well, yeah. So this should be 50% AT content because it's half A's and half G's. Does that make sense? Like I want to know the ATs of the string. This could be anything, right? So it should at this point still be 50% AT content, right?
Okay.
Or imagine I had done something more complex like A, T, T, C, G, G, A, you know, like a real genome sequence that you wanted to know the GC content or the AT content. I just gave you a really like low complexity example so that we would know the right answer without trying very hard. Okay, so the first thing we're gonna do is say, I wanna define a new function and I'm gonna call it get AT content because that is a smart name and I'm gonna remember what that function does because the name says what it does. The next thing we have to do is define that this function takes an argument. I'm gonna call this argument DNA. And then I'm gonna put a colon. So this is always the first line of defining a function. Def, the name of the function, an argument or multiple arguments that you want the function to take, and then a colon. This whole colon, and after the colon, you get a block of indented text. You saw that with the for loop. It's similar for a function. Everything inside the function at this point must be indented. If you're going to use 4 spaces, use 4 spaces for every line you want inside the function. If you're going to be a tab person, use 1 tab for every line you want to be inside the function. So now we have this DNA variable. So we're not going to, it's going to be dynamically defined when the function gets called. So we don't want to specify what it is because we want this function to be flexible. We want it to be able to take any argument. We still need to know the length. Here, maybe it would just be easier if I call this my DNA, and then the rest of our code will work. We still want to get the count of the A's. We still want to get the count of the T's. We still want to get the AT count. And at this point, we may still, maybe we want to print it. Okay, so once we stop indenting lines, the function is over. Python's like, okay, I know what that function means. I've got all the indented lines. I'm gonna run all of those when you call the function. And then you're back to regular Python again, and you can call the function. So at this point, you can say get AT content. You are going to provide a string in the parentheses as an argument. So Python's gonna say, oh, okay, I know this function. I've seen it defined. I'm going to run it. Get AT content, my DNA. I'm gonna assign whatever argument you gave me to the variable, my DNA, and then go through all of these lines of code and do whatever the function tells me to do. Check that out. So we've managed to accomplish the same thing, but now we have this super flexible, reusable thing. I'm gonna write that out. Right, so we can just keep reusing it. Yay, functions, they're fun. Okay, so a few things that I am not doing particularly great in this function is I should probably return the value instead of printing it. So one of the things, like if you care about GC content or AT content, you might not always want to print it to the terminal. You might want to print it to a file. You might want to use that as a variable that you put into another calculation. So it's actually not that convenient. It really limits the utility of your function if it prints the screen, because it defines what do you want to do with this information. So functions are best when they deal with a very small bite-sized problems that are very easy to reuse in other ways. So if you don't have to make a decision in a function, like the fact that I want to print this to the screen, it's better to just return the variable, and then later on in the Python code, you can figure out what you want to do with it. So, wait, I should not have done that. AT content. Okay, so at this point, if we return AT content, but we haven't printed it to the screen. So if I run that, nothing happens because we're not doing anything. We've assigned it to a variable. We're sending it back out at the end of this function, but we're not doing anything with it. So one of the things we could do is print it. Another thing we can do is assign it to a variable. And then we could print that variable. Does that make sense? So when the function returns, it's sending that value back out, and you can do whatever you want with it. Print it, assign it to a variable, put it into an addition, put it into something else. Any questions on that? Does that sort of make sense? Yes.
So when you're returning the content, but you're not assigning it a variable?
It does not get a name. Unless you assign it a name, and you have to assign it the variable name when you run the function.
Okay.
So it's just like when you run count and you say my string.count a, that value exists and it comes back from count, but you have to make the decision of whether you're going to print it or store it somewhere or do something with it. So this function works just, your brand new function that you've just written works just like a function like count, except now you get to see how the innards work. You get to see under the hood of the functions. What do I want to do next? Store the result in a variable. So it's important to point out this from the example. What I'm trying to show you is that each time we call the function, my DNA holds something different. My DNA is getting assigned. It happens on the fly. I say get AT content, and whatever you put in the argument right then, that's what my DNA holds. And then like the next time you say get AT content, if you send it, you send it a different value as the argument, and that gets assigned to my DNA. So my DNA is totally dynamic. It is a variable that points to whatever you tell it to at the time you call the function. If that makes sense. Okay, so let's talk about scoping. Scoping is not obvious when you're learning how to code. So in this case, and this is true of for loops too, I mean, but okay, let's not think about that yet. My DNA has a scope. My DNA, poof, comes into existence when you call the function. And when the function returns the value, my DNA goes poof and it's gone. So my DNA, its scope is the function only. It is defined as a part of the function. It is never, it does not exist once that function returns. So if I do print my DNA and save that, my DNA is not defined. That's because when you start this block of code where everything's indented, everything that gets created inside of that block of code, it lives only in that function. It lives only to serve that little item. It doesn't, and then when it returns, it's not persistent. So the scope of the variable is my DNA. And that's true if we created some other thing up here, like it's not just arguments. Oh. My other var is still not defined. So it's defined in the scope of the function, but it's not defined outside the scope of the function. So important to know. Difficult inputs. Okay, so we've neglected to make this a particularly flexible function. So what if I had lowercase? It gives us a 0, which is not expected because we think of this as giving us AT content. So it doesn't even fail. It just gives us a number, which is not correct. So I would consider this a bug. This is our first bug. So what are we going to do about that? Any ideas? Yep.
Change the capital A to the lowercase.
So what if I had like that? Ooh, I don't know if you can give it a list like that. Will count take a list? I don't know if it will. You could check for A and lowercase a and T and lowercase t. The other thing you can do is just make my DNA uppercase with the upper command. Those are good answers. You would have eventually struck upon something that worked. So this is a relatively simple way.
Can you do something like for lowercase a do this? So,
If lowercase a do this.
yeah, if lowercase a, I don't know, either change it to a big A or just count it as something.
Yes, and we will learn if-else statements maybe by the end of the lesson today. So yes, decision making is helpful. Sometimes homogenizing your input is the easiest way instead of trying to like guess all the possible things that people could give you. But sometimes you have to guess all the possible things that people will give you. But if you can just homogenize your input, that's also really pretty convenient. The other thing we can do, so this gives us lots and lots of numbers that we may not want. Let's see if I can make that bigger. Can you guys, is anyone having trouble seeing? Is that okay? So we could take another argument. We could take a significant digits argument. And then there's this great little function called round, where you round content to the number of significant digits. So maybe it'll be simpler if I show, no, that's great. So in this case, we're going to provide a second argument called sig_dig. We are going to return the AT content as a rounded value, and it's going to round it to the number of significant digits that we tell it to round it to. So now it's going to round it to 2 significant digits. This is an example of how you can add as many arguments as you want, however many arguments you need to make your function work the way you want it to work. We can also add a default. So what if we wanted to maybe not always have to say the significant digits are 2? Okay, and a good example of this, you remember when we learned the open command. If you just open a file and don't say anything else about it, it opens the file for reading. But if you want to open the file for writing, you have to give it a second argument, which was the W. You had to put as a second argument. So this is an example of where we're gonna say, if you don't tell me what you want the argument to be, I'm gonna assume you mean 2. I have a default value. If you specify it, great. But if you don't, then I'm gonna assume you mean 2. And you specify that default up here in the when you're defining the function, you go ahead and give it a default assignment. But if you overwrite this by calling it with something else, a different argument, it'll just overwrite that too with whatever you provided. So let's see that. What if we, let's try a couple different things. We'll make that one 3, and we'll make that one no second argument. So this one, we specified we wanted the significant digits to be 2. Great, no problem, 2 significant digits. In this one, we were lazy and we just didn't specify that second argument. So the function said, okay, that's okay, I've got a default value, no problem. In this case, we specified the significant digits to be 3. Again, the function says, okay, no problem, we'll use 3 instead of 2. And we get 3 significant digits. Functions don't always have to take an argument, but they don't tend to be very useful if they don't take an argument. Like they're not very flexible. So if you just have something that like my function and all it does is print to the screen, it's just, that's like the first sign that you're probably not making something into a function that needs to be a function. Functions generally need arguments. If you have a function that doesn't need an argument, you need a really good justification in your mind for what that's doing. And there's some more examples in the book. Like you could define a function where you, like we did at the very beginning of the lesson, where you hard code in a DNA sequence and calculate the AT content and print it to the screen. You can shove all of that into a function, but is the function really doing anything useful? Why would you want to call it multiple times? Functions are usually there to take some input and do the same thing over and over and over again, right? Like if you have a function that knows how to chop vegetables, you want to be able to give it an onion and give it a bell pepper and give it a zucchini, and it can consistently do the same thing over and over on different inputs. So it's rare to see a function that doesn't take arguments. So caution, if you're making a function that doesn't have any arguments, you may not be doing the right thing. Functions don't always have to return a value. So initially we did not return a value, we printed it to the screen. But again, that makes a function that's less flexible. So usually functions that return a value are better than functions that don't return a value. Functions can be called with named arguments. Okay, so let's see that. In this case, I can actually tell the function what I want the arguments to be. So this wouldn't seem to be very helpful because they're already in the right order. But if we wanted to put them in a different order and there were lots of arguments, we could do that. So in this case, we said take the significant digit parameter or argument, and I want it to be 10, and my DNA, I want to be this other thing, and I put them out of order. And we can do that because we name them, because we specify which argument goes with which input, right? So that Python can figure it out. You can't reverse the order if you're not naming them, but you'll see that sometimes in Python code, so it's important to know that it exists. You should not, in general, mix and match. If you're going to name all of your arguments, name all of your arguments. If you're not going to name your arguments, put them in the right order and don't name any of them. You can't actually mix and match. It will sort of allow you to do that. But once you start naming an argument, every argument after that has to be named, and the arguments before don't have to be named. Just don't do that, because it's just bad and it's confusing. Like, if you're going to call out each and every argument by its name, do them all. And if you're not going to use any of the names, don't just put them in order and don't use any of them, but don't mix and match. Okay, we covered defaults. Okay, so it's good to test your functions. I'm gonna get rid of all of this actually. So this gets more important when you have complicated things going on in your program. So when you write a function that does something complicated, and then you go in and you debug it or you change it, it's nice to know if you broke it. Because sometimes in the process of trying to fix something, you actually end up breaking something else. So they have these things that you can write in Python called assertion tests. And it starts with the word assert. So we could assert that get AT content should be equivalent to 0.5. In this case, we're using two equal signs. And we'll see this, I think, in the next chapter. Yeah. But double equals is an equivalence. Are these two things equal? Whereas a single equal sign is assignment. So x equals 3 is assigning the value of 3 to the variable of x. So single equal sign is assignment. Two equal sign is asking the question, are these two things equivalent? Okay, and this will default to 2 significant digits. So in this case, it doesn't return anything, but that's because our test passed. If our test fails, oh, should have failed, 0.4. I get an assertion error telling me that, I guess in Python's world, 0.5 and 0.50 are they are equivalent in numerical terms. So that passed. But if we say that should yield 40% AT content, then that fails and it tells you you have broken your function. It no longer works the way you think it works. So a good one might be, one of the best reasons to do tests is to define your edge cases. And that just means define anything unusual. And we joke around a lot in my lab when we're writing software about, like, no matter what you think is obvious, a user will find some way to do something completely unobvious with it. You will get input that you never expected, and you must be prepared to handle all situations gracefully. So what you want to test is a lot of edge cases. Like, what if someone gave me something totally nonsensical or something unexpected? Like, how will my function handle it? So in this case, what if somebody included some ins in their input? You can make some decisions about what you want this to say, but in most scenarios, you want this to be a 50%. You want the ins to get ignored. Because you don't know if they're ACs, Ts, or Gs. So if you ignore them, you're safe. So let's see what happens. It does not equal 0.5. Let's see what it does equal. Oh, I have to comment out my assertion error. Yeah, so when the assert fails, it kills the program. The program stops running. .18. So it's using the entire length of the string instead of getting rid of the ends. So one of the things we can do is replace all of the ends with nothing. Not with spaces, because spaces have length, but with nothing. Now we're getting our expected 50%. Again, there's multiple ways you could probably do this. You could try to count the number of C's and G's and then use that plus your A's and T's to do the length and then ignore everything other than ends. But this is an easy way to get rid of them. Yeah. Okay. Could you do, so there's generally, I mean, programming is a very creative endeavor. There's usually many different ways to arrive at the same solution. And just using your toolkit to arrive at something that consistently works is the goal. We have a new policy in my lab where before you write a function, you have to write all of your assertions first. You're not allowed to write the function until you know what the function wants to do. And that really like enables you to think through the problem well. You need to think through like, what are all the different possible types of input I could get? How do I want to handle each of those types of input? What kind of things do I want to return? What format should they be in? And so you define like maybe 20 assertion statements, because then when you go to write your function, you know exactly what it should behave like. You've defined all of your edge cases, you defined your behavior, and you can write the function correctly the first time. At least that's my theory. I don't know if it's working, but that's our new rule. Yeah, so it's common to have a lot of different assertions down at the bottom below a function, and to just test a whole bunch of different things, just to make sure they all work. And this is nice too, because they just live in the middle of your program, and if they all pass, your program just keeps moving. So it doesn't impact your output, it doesn't impact the rest of the flow of your program. If you just keep your assertions living with your function, it's good because it's always testing to make sure your function is working the way you think it is, but they're not really getting in the way. What's another thing we could test? We could test a single letter. And all of those passed. And I think I would test an empty string, but I think I would have to use a conditional to fix that error, and we haven't learned those yet. So maybe we'll do that in a minute. Currently we can't program our way out of an empty string, I don't think. Yeah, not that I can come up with. Okay, so questions about functions. Okay, so there are two homework exercises, but I thought it might be a little bit more informative if we just go through them as a class, because I feel like that's kind of a quick lesson on a big topic. And it also allows me to show you a little bit more about how I program, which I think is helpful, because it looks, when I'm like following my little notes and just typing it, like you write a program like you write a paper, which is you just start at sentence 1 and keep typing. And that's really not how you do it at all. It's usually a much more iterative process. So in this homework example, the question is to write a function that takes 2 arguments. The first one being a protein sequence, and the second one is an amino acid residue code, and then returns the percentage of the protein that the amino acid makes up. So it's basically a more flexible version of our AT content. But you're gonna specify what the content is. So the first thing I might do is comment out what I have, but not get rid of it. But I feel really good that this code is gonna be helpful. So I don't wanna not be able to look at it. I want it to be down there at the bottom, and I will delete it before I send it to anybody, but just so I have it as a reference. Okay, so following by our best practices, we're gonna write some assertions first. May or may not have made that match the book. Okay, so I think there's one in, and that should be like 20 amino acids. So that should be a 5%. if we count the r's, even though we gave it to a lowercase, we want that to give us 10% because there are 2 r's. L's make up 50%. And what if we give it an amino acid that is not in there? That should tell us 0%. Okay, so we know what we want our function to do. I don't love the name of my function, but I've already typed it 4 times, so we're gonna stick with it. Get AA content would probably be like a better name, but okay. So the first thing we want to do is set up an argument. What do we want to name our first argument? What would be a good name? Protein. Protein would be great. And our second one, just to make it short, we could call it amino acid. So we want to know, so this helps us to remember that the protein is first and the amino acid is the second argument. Then we need our colon. So we've set up our basic definition line. And again, you can always look down here to something that you've already done and be like, okay, yep, that matches. I remember how this works. The next thing we might want to do, in this case, there's no letters that we know of that we definitely want to replace, so we're not going to worry about that. So then it makes sense that you would probably want to keep the length. And then in this case, I was counting based on something I knew I wanted. I knew I wanted A's and T's. In this case, I'm going to have to be flexible. I don't know what I want to count until the user tells me, or until the program calls the function and dynamically tells me what that amino acid is. So I still want to get the count. Probably makes sense to do an upper again. But in this case, instead of telling it I want an A or a T, since I don't know what I want, I'm going to give it the variable. And then at this point, I've written a lot and I don't know if it's working. So I might just return AA count and see how far have I gotten? Or you might even have like stopped to just return the length just to make sure you have something that's kind of sort of working. We'll print. Okay, so I have my function. I'm going to send it MRS and M just as a test case. And what I expect to happen is that I'll get the length of the protein, and that'll get stored in a variable called length. And then I'll get this AA count, which is going to be MRS.upper.count. We're hoping that count's going to hold that M. So we expect that to be a 1, and then I'm going to return that 1. So at this point, that's what we hope our program is doing. I can go here. And I have a problem. My assertion is failing. So this is the problem with writing your assertions first, is they don't always work. We're not ready for these guys yet. I think it's still a useful exercise to write them. All right, let's go back here. And it prints 1. We know we've got something that kind of sort of works. We're getting the right count. So what did we do next? Okay, so we used our length and our count to get the percentage. So let me go back up here. AA content this time. And AA count divided by length. And then now I can think, okay, I actually want to return that division, right? So let's save that and see how far we made it here. Ooh, okay, so now we're getting a fraction, but the assertion statements want a whole number. So how are we gonna go about getting a whole number? Like a whole number for the percent. Well, the integer would be, like, so it's not an integer, it's a 0.33. How would you do it if it was in Excel? You would what? Multiply by 100. Yes. Which is, yes, sort of like converting to an integer, where you're just going to multiply by 100 because it's a fraction and you don't want it to be a fraction because that's not what your assert statements have requested. Okay, so 33.33. At this point, maybe we want to round it, but maybe we're being lazy and we don't actually care to let people tell us how much they want to round it. We're just going to round it to one significant digit every time. Okay, so looking better. So do we think this assert statement would work? Well, let's go see which ones of our assert statements are working. Okay, that one worked. It didn't tell me assertion failed, so that's a good sign. Let's try the next one. Oh, that assertion failed. So lowercase r failed. Any idea where you might want to try to fix that? Yeah, AA.upper. So we'll force our amino acid to be uppercase. If we force our amino acid to be uppercase and our protein to be uppercase, we'll use all uppercase letters. All right, let's see if we've got that assertion passing yet. Yay. Okay, let's go down to our next one. That one passed. And that one passed. So that's a more realistic example of how you might want to build up a piece of code or a function, is write 1 or 2 lines of code, super simple, and then print some results or test it. Try to figure out like how far have I gotten? Are the variables holding what I think they're holding? That's good. The other thing I do a lot of is lots of print statements. So you could say print protein is plus protein. Print amino acid is plus amino acid. And print length is plus length. And then as it's looping through, every time you call that function, it's going to give you all those print statements. You can say, okay, I feel confident protein is holding what I expect it to be holding. The amino acid is holding what I expect it to be holding. The length is holding what I expect it to be holding. So it helps you to like see the insides, like how is your function working as you're building it up. And then at the end, potentially you don't want all of that. So I often leave it in there in case I ever need to debug. But just comment those print statements out. And now I'm back to something that doesn't give me all of that extra stuff on the terminal because I know it works. But one day when it stops working because I've broken it or I found a bug, I can go uncomment all those prints and see what's going wrong. I don't know if that's an approved method according to the book that we're using, but that's how I do it. And I think it's super useful. But that really just helps you to see what variable is holding what inside of this function. What's going on? How am I doing this right? I'm not getting the result I want. Exactly where is it going wrong? So those are the types of questions that you want to be answering. Okay, another fun problem. We're gonna just build a crazy program now. Next exercise. Modify the function from part 1 so that it accepts a list of amino acid residues rather than a single amino acid residue. If no list is given, the function should return the percentage of hydrophobic amino acid residues, A, I, L, M, F, W, Y, and B, your function should pass the following assertions. So this is getting more complicated. We need to add a list. So now that we don't need all of this stuff down here, I'm going to get rid of it. Yeah, this is why you just buckle down and learn BI. Okay, so if I were doing this in BI, I'm literally going to hit D, capital G, gone. I could say change all of the asserts to prints, done. Like you just, it takes like 3 months, but you will be so fast. That's why like teaching this class kind of drives me crazy because like Nano is the worst. It is the worst. But it's like, it's just so much more powerful. And like I just typed like YYP and I can like copy and paste the whole line. And so like once you learn BI, and Emacs is the same. It's like a super fast language where you just learn to do everything on the keyboard and you can do everything super, super fast. I mean like double D is to lead a line. And I mean, you guys should just go learn it. Like go take a tutorial. It's amazing. But I felt like it would just be like another thing you had to do during the week to like learn, and it would be, it's a learning curve. I don't know. Some people in my lab hate it. Some people in my lab love it. So I try not to force it on people. My husband and I were both computer science undergrads at Clemson, and we took the same class, and the professor was so passionate about BI, and he made us learn it. But it like divided the whole class. Like some people loved it and some people hated it. And I was just like, this is the best thing ever. And Evan thought it was horrible. And we had to go in at the end of the semester. And this was actually the idea for the shell test, is he made us come in and prove to him that we had learned BI. Like he would tell us what to do. We had to see all the little commands. And I passed with flying colors, and I think Evan flunked it and has never forgiven me to this day. But I think it is a lot. Like it takes a lot of practice, but it's really nice, and you get super fast. I don't know. You can also like, if you want to comment out a line of code, you can. It's really fast. It's like 5 keystrokes to do that, and then undo works, which is really nice. Anyway, okay, so you guys should just do that on your own because you want to be fast and good. Okay, so back to Nano, the worst thing ever. Okay, so let's see if we can just edit on top of this function. Okay, so we know we want to take a list. I'm wondering, should I start from scratch? Yeah, let's start from scratch. Sometimes it's hard to decide if you want to try to edit on top of the code you already have or start from scratch. But at the early stages, I would say err on the side of starting from scratch, just so you can like see all the moving parts as you go. This time we'll call it something more intelligent. We'll call it get a percent. We're still going to take a protein, but this time we're going to take an AA list. That's our second argument. So we know what's changed on the definition line. We're going to take a list of things. Okay. So length of the protein, we're still going to need that, so we can keep that part. Okay, so good. We feel like we've already made some progress. And at this point, you might actually want to go ahead and start testing, like do get AA percent with 2 arguments and make sure you're getting the right length, just that you have everything in the right place. But the next thing we have to do is deal with this list situation. Assuming I had something like, we would expect the M and the S to be 3/4 of the sequence we gave it. We would have to count. So this is when you have to start thinking about what's my strategy? What's my strategy for building this function? Well, I just did it in my head. So what did I do? I said, okay, well, there's one M and then there's two S's, and then I have to add those together. That's a really good starting point for how you want your function to work. So thinking, okay, I'm gonna have to go through this list. I'm gonna have to find each amino acid individually and get their counts. So anybody remember how to iterate over a list? I think we learned this. We learned a for loop, right? Yeah. And this was the first time we learned the whole like colon indentation system. So now we have a loop inside of a function. So in this case, we have to indent twice. So anything inside of the for loop, we want to indent that twice. So at this point, because this is a totally new construct and we're probably all feeling a little nervous about it, we will just print the AA and make sure that it is looping through and getting them correctly. So let's do our print statement so that we can see what's happening. I don't know if that'll actually work. I can't remember. Length and for AA. So let's. Okay, it's not going to print a list. I think we have to coerce it to a string. Okay, so what we have now, we're using our super simple little example down here. We start at the top of our function. Protein is MSRS. Awesome, we have our protein where we expect it to be. AA list is M and S, great. We have stored a list in a variable. It is inside our function, that is working correctly. Next, we're getting the length. I'm not printing the length, but we can presume because we have used len many, many times that that's probably doing what we expect. The next thing is our new for construct, our for loop. For AA in AA list. So we're gonna iterate over that list of amino acids and get them one by one. So first part of the list, we get an M. Second part, we get an S. So it is going through our list one by one by one. So what did we want to do with each one of these things? I just said it. So we ultimately want to get to having the total percent composition of our protein with this. So for the M, what do we want to know about that M? What we want to know is how many times it occurs in our protein. So in this case, I might look down here and be like, okay, well, I know how to do that. I've got a count function. We'll call it AA count. We're gonna use that same line, and now let's print AA count. We're taking our protein, we're making it uppercase, just in case somebody gave us some lowercase variables. And we're counting the number of times we see the amino acid. And just to be safe, we'll make the amino acid uppercase too. We're gonna store that value in a variable called AA count and print that out to see how we're doing. Okay, so this is great because now we know that there's one M and there are two S's. So we're getting closer. We are now able to count all of the things in our list and we have the total length. So now all we need to do is add up all the things in our list and divide by the length. So in this case, this is something you haven't seen before and has to do with scoping. You can start a variable outside the scope and then use it within the scope of a loop. So in this case, I'm gonna create a variable called total. And I'm gonna use that to keep track of the total number of times I see an amino acid I care about. Okay, so this is a completely new thing. So I start here in the function with a total of 0. I've seen 0 things that I care about. The first time through this for loop, I'm gonna see the M. And I'm gonna say, okay, great. How many M's do I have in this protein? The answer is 1. So I'm gonna say my total equals what the total was before plus 1. So 0 plus 1 is 1. I'm gonna take that 1 and assign it back to total. I'm gonna start back over on this loop. Next time, I'm going to see the S. I'll say, okay, great. How many S's do I have in this protein? You have 2 S's. So I'll say, okay, we'll take my total, which is currently 1, add a 2 to it. That'll make it 3. And then when I exit the loop, I will have been keeping a running total of the number of things that I saw. And again, everything I want to occur inside the for loop has to be indented twice. And then, okay, so we're back down here. Like, okay, we had this useful line down here. It looks like that's still going to be pretty useful. Ooh, a content. Oh, no. I almost made a problem. I made an error. We're using total now because we're adding them. And then now that I'm actually returning something, we can print this out. And just to continue making this more and more convoluted, we'll have to coerce that to a string. So at this point, we want to see, hopefully content is 75. We'll see. Yeah. So again, I'm adding more lines at once than you would probably want to do. You would probably want to add like one little thing and then print and try to make sure it's doing what you're thinking. Then add one other little thing and then try to print and make sure it's doing what you think it's doing. Do you guys have a question?
Weird comments online.
Oh, really?
Yeah, it's it gives me everything that I'm having it checked off except for I think it's having a hard time with for loop because it's saying built-in method count string object at. It's
Are you
not
trying
even
to
saying error. It's just saying that.
All right. Well, we'll be done in a few minutes and I'll take a look. Yeah, I don't know if you know a lot of Python. So yeah, okay. We can figure it out. Not a problem. Okay, so now we can try some new stuff. Let's try. What if our list only had one item? Would it work? Yep, it likes that. Okay. I'm going to guess 77.8 is correct. I don't know. Probably pretty close. We could have maybe tried an example that was easier to count. We could do all S's with a one item. That's 100%. So that seems like that works pretty well. Oh, another part of the problem that we haven't dealt with is that if no list is given, the function should return the percentage of hydrophobic amino acid residues, AILMFWYV. So, but that's actually a pretty easy one to deal with because now we know how to set defaults. So we can create a default list. Had to be a lot of these, didn't there? AILMFWYV. Okay, so now we have set a default list. And so if we didn't, now we expect that if we don't specify a list, it will hopefully work. So we could test this in two ways. Maybe if we give it all letters we expect to be there. That one should return 100%. And then if we give it a whole bunch of letters that aren't in there, that one should turn 0%. And then maybe if we do half and half, that should return 50%. Oh. And this would be a good time to go comment out all these print statements so they don't take up all the room on your terminal. So we get 75%, we're getting 100, 100, 0, and 50. So these would be, now that you have tested them with print, these would be great things to turn into assert statements and make sure, and you will always know if you're asserting these things are true, asserting that, you know, this one, oh, yeah, sorry, let me go back to the top. So yeah, you could say assert get AA% SSS with a single. That should always be equal to 100. Is that how you would do your assert statements? And in case, and when it passes the assertion, it just doesn't do anything, but you know it's working, so that's nice. So that's how you build little functions and programs. I think they solve it in a slightly different way in the book, but they both work, which is all that matters. All right, so we had a few more minutes. Let's real quick, because you can get extra credit on the homework that was assigned today if you understand conditionals. So let's do a quick conditional. Oops. Okay, so conditionals are great because they allow you to have logic in your program. They allow you to have decision making. A condition is basically any piece of code that produces a true or a false statement. So let's see some examples. I can make this much smaller. Oh, smaller again. So if I say print 3 equals 5, it says false. That is not a thing that is true. And this is, again, using the double equals as a equivalency. A single equals is assigning a variable something, a value. Whereas double equals is always like, are these two things equal? What if we said 5 is greater than 3? Now we have false on the first one, but true on the second one. Another good conditional to know is 5 is greater than or equal to 3. So if we do the greater than and equal mushed together, it means greater than or equal. If we do less than and equal mushed together, that means less than or equal. So in this case, the equals is still true. It's not greater, it's equal, so either one. We can have somewhat more complicated conditionals. Oh, let me put one. Is the length of ACTG equal to 4? True. You could do count Oh, and this is a new, this is fun. So just because you haven't given it, you can use a string without having a variable name. So instead of giving this a variable, like assigning a variable to GAATTC, and then using that variable.count, I can just put that whole string as like the subject of that method. There's a method called starts with that is another example. Starts with G, and maybe we'll do one that's, no, it's not gonna work. So starts with G is true, starts with A is false. So there's lots of methods in the world that give you true, false answers. And what you normally want to do with them is make a decision. But true, okay, so true and false are special, they're special words in Python, kind of like print or len. They're not words that you ever want to assign a variable, make into a variable name, for example. They're, so that'll actually print the word true, where if we tried to do name hello is not defined. So it tells you true has a definition. True is a thing. True is an object in Python that is true, and false are values that can be logically operated on. They're called Booleans. Boolean logic is how you get a true or a false. All of these conditions are some type of logic. Is this the case? You get a true or a false. So true and a false are just, I don't know how to express that. They're just special. They're like special values. Okay, so we talked about double equals is equivalence, greater than and less than, greater than and equal to, less than and equal to. Oh, another good one is not equal to. Oh, let me get rid of all this stuff. Oh, really? Oh, well, that's good to know. Okay, we'll be using that a lot. So 3 not equal to 3 is indeed false because 3 is equal to 3, but not equals to is the exclamation point equals. And this is pretty common across programming languages. But so what could you do with this information? You can write if statements. So you say, if this thing is true, do this. So let's say we had expression level equals 125. If expression level is greater than 100, print is highly expressed. Now we know Control K. Oh, yes, that's much faster. I don't know. Sometimes I feel like it's good for me to have to do things the slow way because I kind of move fast and type fast. So that may or may not be good. We'll see. Oh, I have a backtick randomly at the end of my line. Okay, so this is another one of these like block situations where you have a colon and then a block of things. So like a for loop or like a function definition, after I put this if, it starts with the word if, that's your keyword, just like for or def, start with if, and then you put something that can be evaluated to true or false. In this case, we have is our expression level greater than 100 is our conditional. If that evaluates to true, the code block, the indented code block will be executed. If it evaluates to false, the indented code block will not be executed. So this is making your programs smarter. So if we change it to 25, we expect this to evaluate to false. It doesn't print anything. Else. So what if you want to do, it evaluates to false, but you still want to do something different about that. There is an else statement. In this case, your else is not going to take a conditional. Your else is completely and totally dependent on the outcome of the if. Else only gets executed if the if fails. So in this case, we can now, I mean, think about how much you guys have learned in 3 class periods. It's probably a little overwhelming. You could take a huge list of genes in a file with their expression values, read in all the data from the file, figure out which genes are highly or lowly expressed based on whatever arbitrary number you want, and then create 2 new files of highly expressed and lowly expressed genes. And you could do all of that with about 8 lines of Python. Do you feel like that's exciting? I feel like you should feel like that's exciting. It takes practice to figure out how to like get all these moving parts to work together to do what you want them to do. But you now literally have the tools in your hands to write programs like that and to make them work. And that's exciting because that is like the building block of becoming a really good data scientist. What else can we learn? Well, it's about 4. Let's leave it. Oh, we were gonna do for loops. I cannot remember if we read in from files with a for loop last time. I think we did, but I'll show it again real quick. Okay, so let's create a file. Expressions.txt. We'll do 100, 125, and 75. And then we're going to say my file name equals expressions text. My file object equals open my file name. Yep. And then the for loop is for line in my file object. Front line. Okay, so it's printing. We have taken a file, we are opening it, and we're iterating over each line in the file. And now that we've learned to do all of this cool stuff, we could say, what could we do with this? Well, the first thing we might want to do is strip off all of those. Line equals line.rstrip. I don't know if this will work. I think I have to coerce it to something else. I think we want to coerce it to an int. You'd have to be really confident that your file only contained numbers. So in this case, after 125, it's going to print highly expressed. So we have learned how to coerce integers into strings so that we can print them. You can go in the reverse. So if you have something that's being stored as a string and you need it to behave like a number, and you're truly convinced that it only contains something that looks like a number, you can coerce it to an integer. But at this point, you can now do fun things like sort files, and you can now open a file for writing and only write the values of the highly expressed genes and do stuff like that. So that's how you iterate over a file and see all the lines one by one by one, instead of reading all of the file contents into one giant variable. Questions? It's a lot of pattern recognition, like just you'll see the same constructs over and over and over. The homework is 2 short little programs. One's writing like a little just actual script, and one's filling in the defining a function that does something. And that's due next Wednesday. If you guys have any issues or questions about the homework that's due tonight, feel free to stay after class. Thank you. Was that overwhelming? Are you guys in shock? Are you okay? I think no one's moving. Yeah, yeah. Comment. Well, it kind of makes sense because it's like, oh, people are commenting on things again. Yeah.
I don't know, because I don't know what other programs use hats. So I'm just wondering if after a while, like, or if you see like the dollars, you're like, okay, what's going next?
Yeah.
Because R is all like these, I don't know, greater than symbols for like outside of say stuff.
Yeah.
So it's just, I don't know.
It is, yeah. Yeah, hashtag took me a long time because we always said pound sign. And in computer science, exclamation points are called shebangs for some reason, and I don't know why. So like, but that's how like I was taught when I was an undergrad. So I still tend to say shebang. I'm like, nobody uses that except like old men who were 70 when I went to school. It's like such an old school thing to say. So I have to remember not to say shebang.
For the double equals, I guess he learned it as like super duper equals. And so like when I was teaching class, he's like, I had super duper equals. They're like, I don't know what that means.
Because of super duper equals. Okay, that's a fun one. I should start using that.
I know what that means.
Yeah, you want help? I will give you. Yeah. Hold on, let me do her first. Is there anyone who didn't get a test? Oh, yes. Before you leave. So, it's like, yeah, a bunch of people have been having this problem. My recommendation is, are you using PowerShell? Yes. I would switch to Mobax term. Okay. Because I can't figure out how to fix it. Okay. We tried a bunch of different stuff. I think just switching to Mobax term should fix it. Okay. But I know it's super irritating.
Yeah, because I always like take resigns and that normally did the trick, but now it's like
Not working.
yeah, I have to go past 2 times. So like, I don't know. Okay, so
Yeah.
Mobax term?
Mobax term, yeah.